Some of you will have, some of you will not. Filled out this page. Find me this page. Okay, so we were looking at, right before the break, we finished our lab on chemical equations and we did a bunch of balancing stuff, and that was all well and good. We looked at the word equations, we looked at the paragraphs that you had to turn into a word equation, that you had to turn into a skeleton equation that you then had to balance. We did the iron chemist lab, and then we kind of jumped into the awkward world of acids, bases, and salts. We haven't talked about salts yet. We spent time talking about acids and bases, and then you did 2 more labs for me, the ones that I have just mentioned, properties of acids and bases, and which acid is more acidic. I also assigned a whole ton of questions within all of that for you guys to take a look at, and I want to make sure that we are all kind of on the same page with this stuff. So, just to quickly review, if you recall, acids were compounds. The definition that we now have for acids are chemical compounds that release hydrogen ions. And there was a question asked in the other block, my C block class, that you guys didn't ask, and that's fine, but I'll tell you what it is here now. And if you recall what a hydrogen ion is, or if you think about what a hydrogen ion is, hydrogen has an atomic number of 1 and an atomic mass of 1. So if you think back to the very first day that we talked about chemistry, an atomic number of 1 means a hydrogen atom has 1 what? If the atomic number is 1, what does that mean? What particle does it have 1 of if its atomic number is 1? Or another way to ask this, what does the atomic number tell you about an atom? It tells you where it is on the periodic table, but there is a particular particle. It is not the electron. It happens to be the electron sometimes. It is all who said that. Yes. The atomic number tells you how many protons you have. An element is defined by the number of protons that are present. And so hydrogen is number 1, which means it has 1 proton. If the mass is also 1, and it is on the periodic table, the mass of hydrogen is also 1, which means it has no neutrons. If the mass and the atomic number are the same, it means there's no neutrons, because neutrons would add to the mass. So for a hydrogen ion, what a hydrogen ion actually is, to become an ion, hydrogen usually loses an electron, which means if the nucleus is a proton and the only other electron that's there is now gone, because hydrogen has ionized, what's a hydrogen ion? There's no electron because it's gone. There's no neutron because the mass is 1. So a hydrogen ion is just what particle? What's the only particle left? There are no neutrons. There's no electrons. It's just a proton. So a hydrogen ion is only a proton. Which I wasn't going to tell you guys, but then my C block class asked me about it, and so then it came up. So the definition we have for acids is a chemical compound that releases a hydrogen ion or releases protons into a solution. The formula for an acid is generally HA, where H is the hydrogen that gets donated out front of the formula, and then A is the rest of the formula, whatever it is. So I gave you a bunch of examples down here. Hydrochloric acid, sulfuric acid, nitric acid, skip this one, phosphoric, carbonic, and hydrofluoric, and citric all have that H listed out front. Acetic acid, or commonly known as vinegar, has it listed out back. But generally speaking, the formula for an acid has that hydrogen that gets donated out in front of the formula. So that's what an acid is. It's a compound that releases protons or releases hydrogen ions when it's dissolved in a solution. Bases were the opposite. The opposite of a hydrogen ion is a hydroxide ion. Bases are compounds that release hydroxide ions, so OH minus. So the general formula for a base was BOH. So things like NaOH, MgOH, COH2, NH4OH, KOH. These are all bases because when you dissolve these things in water, they donate extra hydroxide. After we talked about acids and bases, this table was some of their properties. I introduced to you guys a pH scale because different kinds of compounds donate hydroxide and hydrogen in different quantities. And so the more acidic something is, the lower down it is on the pH scale. The more basic something is, the higher it is on the pH scale. And if you are smack in the middle, i.e. you have the same amount of hydroxide as you do hydrogen, if you've got the same amount of hydroxide as hydrogen, you're just water. H and OH makes H2O. So you're smack in the middle there. Anything that donates H's pushes it further acidic. Anything that donates OH's pushes it more basic. We also talked about how this scale is what's called a logarithmic scale. It means that every jump of 1 in either direction is 10 times either stronger or weaker, depending on which way you're going. So let's say you started here at water and you started jumping down from a pH of 7 to a pH of 6. Because you're moving in the acidic direction and you've gone a jump of 1 on the pH scale, what that means is that milk and things that have the same pH as milk are 10 times more acidic than water. We jump again, bananas are 10 times more acidic than milk. We don't normally think of bananas and milk as being acidic. They're weak acids, but they're still acids. Tomato is really the first part where we start to say, okay, yeah, this is an acidic thing, and then it gets more acidic as you drop down. But every jump of 1 on the pH scale means you're 10 times more acidic than the thing that came before it. Likewise, as you move upwards, you're becoming 10 times more basic every time you jump a whole number on the pH scale. So we've got acids, we've got bases, we've got the pH scale that measures these things. I gave you guys some questions on this page and the next that I have not gone over yet, but that I did assign. So we'll come back to those in a moment. And then I jumped, because I gave you acids, bases, the pH scale, I jumped straight to the pH indicators, because if we have a scale, we would like to know where we are on the scale. And so I introduced you to a bunch of tests. There are more than these, but I introduced you to 7 of them. Tests that we can do to determine where we are on the pH scale. These tests are made up of different colored chemicals that change color depending on the pH of the solution that they're in. So we had like methyl orange, methyl red, bromethymol blue, litmus, phenolphthalein, indigo carmine, and I told you about the universal indicator. It's the cheater one. And then you guys went ahead and you did a lab. You used methyl orange, you used bromethymol blue, you used litmus, and you used indigo carmine, for those of you who have done this one already, to determine the acidic, neutral, or basic nature of 4 unknown compounds. Then, some of you, 11 of you, I think, 11, yes, went and looked at the second lab, which is most acidic, and you played with phenolphthalein, which is actually kind of like this color, really bright pink, when you put it in a base. And then I gave you a couple more pages of questions just to help your understanding. How do you play with the scale? And the indicators, they change at different rates. So then I got pH indicators, and I had a bunch of questions there. And then I didn't assign this page here, acids versus bases. I said to leave it and we'd come back to it. And that was where we ended my formal teaching before the break. And I gave you guys a couple days to do a couple labs. Some of you finished, some of you did not. So what we're going to do today, and it's the same thing I got my C block class to do, so hopefully by the end of today, you guys will be on the same spot again, amen, as the other Science 10 class, and we can all move forward together tomorrow. Anyone who has not finished either or both of those labs is where I would like you guys to start today. I've got them both set up. The properties of acids and bases, the chemicals for that can be found in that back corner on the same table as the trucks. If you did finish it and just have questions to do, put a pause on that. And then I want jump to the second lab. The second lab was which is most acidic. That's set up and all the chemicals you need for it is up here. Once you've got the data done for that guy, you can jump to the questions on each lab set. And if you are done both labs, but still have not finished these questions, the pH scale questions, the indicator questions, and now I'm going to add this page, the acid versus bases page. That is what anyone who's handed in both lab sets, that is what I want you guys to spend time working on today. Today is functionally going to be a work block to get all of us caught up onto that same spot. If you need, for those of you who don't have, the handouts for either of those labs, in a moment, I just have to grab them from the front. They're going to be on these desks here next to John. And if any of you have finished absolutely everything, you've got any questions to do, you've handed in both your labs, let me know, just so I know who we are and what we can work on this, or whether or not we have to work on anything. So that is what we're doing today. We're consolidating some of this acid-base pH indicator stuff. And if you're absolutely done everything, call me over and we'll talk. Questions before you are free to go. Brooklyn, you got your hand up, check to go. Okay, on your mark it set giver, if you're working on labs, grab goggles. All of the equipment that you need can be found in the carts and tables over there. Go. That both of them. If you need to get both labs done today, take all your data, do the questions after. Everything else on the foundation. No, that's not the That's the pH. It says you need a 4x6. We don't have a 4x3. Find someone to work with. Ideally, there will be someone that can probably do that. That's great. Okay, you guys are here. No, we didn't. Right there. I would think. That's fine. I just want to make sure you have it. Okay. Okay. Yeah. So after these two questions, basically. Nope. Now I'm giving you. Then you'll be done. And you had full labs? This one is that back right where you're sitting next to where you were. As soon as you start getting chemicals, it's all what you do on your face. Yeah. Yeah, but you need to get closer to 4x6, that's only 4x3, so you need to move the Okay. It was really good. My wife and I went to Chicago for a week. It was fun. It was an interesting city. Yeah. Sorry? We didn't go on a river cruise, but we walked. I mean, they've got so many bridges. We walked over it a bunch. It had been colored. I don't know if you know, they color it green for St. Patrick's Day. Yeah, they dye the whole river, which can't be good, but that's what they do. It was pretty cool. How about you?